Hello everybody. So today we're going to look at graphing quadratics in vertex form. So we're going to use our knowledge that we just took in from understanding what each part of vertex form does and apply that to creating the graph ourselves. Now, remember that vertex form is y equals a times x minus h squared plus k. Right? We're going to need to know that. I'm going to go ahead and say we're not going to do this in this video, so you can ignore it for now. Okay, this little warm-up activity. But what we're going to do is we're going to just practice, okay? So we have y equals x minus 5 squared minus 3. Okay, so the first thing we want to do is identify the vertex. And I have h and k. Remember, they tell me the vertex. So my vertex here would be at 5, negative 3. Remember, the h value is always opposite of what you think because it's x minus h in the formula. Remember, it's y equals a times x minus h squared plus k. It's that minus h. Okay, so I'm going to go ahead and go right 5, down 3. Oh. And there's going to be where my vertex is. Now, I should look at this right away and know it's going to open concave up because it has a positive a value. There is no negative number in front of that set of parentheses. And in fact, the way I like to think of this is like I've kind of dealt with these two. I've used the minus 5 and I've used the minus 3. That is what has shifted the vertex from 0, 0 over to the 5, negative 3. And in fact, I like to say that instead of moving the parabola, you're kind of moving the x and y axis. All right. Now, we're not literally moving them. And these dotted lines I just drew in don't actually exist, but it's a good way to think of what's going on to make this easier for you. Now, I then say create a table of values. What I'm talking about here is we have our input x, and what's left over in our equation now that we've taken care of the minus 5 and the minus 3? Well, just x and squared. So my output is x squared. Well, I'm going to use negative 2, negative 1, 0, 1, and 2 because that's the left side of the parabola and the right side of the parabola. Just numbers on the left, numbers on the right. And I'm going to plug it into squaring because that's all I have left to do, right? I did the minus 5, I did the minus 3. I used those numbers. So they served their purpose. So I'm going to take the minus 2, I'm going to square it. Negative 2 squared is 4. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0, 1 times 1, 2 times 2. Okay, now here's the trick. Instead of counting from the 0, 0 mark like we normally do, I am going to count from our vertex, our new vertex. Remember, it's like we made a new set of x and y axes. That's what using the negative 5 and the negative 3 did. So I'm going to go ahead and count from the vertex. I go right 1, up 1. I go right 2, excuse me, and up 1, 2, 3, 4. I go left 1, up 1. I go left 2 and up 1, 2, 3, 4. And there's my parabola. All right, let's try that again. All right, x plus 1 squared plus 4. All right, my vertex, negative 1, comma 4. Remember, this is left 1, up 4. Because that the h value is always the opposite of what you think. I've taken care of those numbers. I've used them. So now I just have the x squared again. So I have x and x squared. Negative 2, negative 1, 0, 1, 2. This isn't different, right? So now I just go to -1 up 4. And I go right 1 up 1, right 2 up. I'll go a little bit off, but we'll live, right? And keep going with that. And we have another parabola. And there you go. This is actually pretty easy. Let's try another one. This one's a little bit harder. First thing you want to do is find the vertex. Now remember that a value of 3 here, where it's y equals 3 times x minus 1 squared plus 1, that 3 does not change the location of the vertex whatsoever. It's only here where it's telling me to go right 1 and up 1. So I'm going to go right 1, up 1, drop a point, and now I've used these numbers. My vertex is at 1, 1. Now I want to create a table of values. What do I have left over? Well, my inputs are x, and I have 3x squared left. -2, -1, 0, 1, and 2. And remember, it's kind of like we have our axes that moved. These dotted lines aren't really there. They're just to help us visualize what's going on here. All right, so -2 squared is 4 times 3 is 12. -1 squared is 1 times 3 is 3. 0 squared is 0 times 3 is 0. 3, 12. We should know that those are symmetrical based on our knowledge from before. And look at that. We're obviously not going to be able to go up 12 on this grade, but I think we get the point that it's a really tall and skinny parabola. All right. Let's try one last example. -1/2 times x minus 3 squared plus 4. Okay. So this is going right 3, up 4. Right? So my vertex is at 3, comma 4. That takes care of those numbers. So I'm going to go right 3, up 4. And there's my vertex. Now what am I left with? So for my, I always have x for my input, but then I have -1/2 x squared left over. So -1/2 x squared. All right. So -2 squared is 4. And then a -1/2 of 4 is -2. -1 squared is 1. A -1/2 of 1 is a -1/2. 0, -1/2, -2. So I go left 1, down 1/2, right 1, down 1/2. I go left 2, down 2, right 2, down 2. And then I got another parabola. There you go. And this one's a little bit wider, and it's flipped upside down. I should have known that right away from the -a value. All right. Thanks, everybody, and have a good day.